Hi, welcome to this next lesson in developing spatial thinking. Today we're going to be going over rotations about multiple axes. So let's jump in with a recap about rotations around a single axis. Rotations around a single axis is a scenario where you're given an axis and a direction, and you're told to rotate an object around that axis in that direction. And remember that we increment or decrement in 90 degrees, meaning we rotate an object at a right angle, either positively or negatively. Now these are dissimilar to solids of revolution, and surfaces of revolution for that matter. Rotate a curve around an axis at 360 degrees. So this is slightly different. Like I mentioned, we can have positive and negative rotation, and we rotate at 90-degree increments. We can have a positive rotation around the z-axis, which looks like we're pushing the object back, or we can have a negative rotation around the z-axis, which looks like we're pushing the object into the floor. And we notate positive and negative rotations with a plus z or a negative z, and then an arrow corresponding to that direction. Now let's look into what rotations about multiple axes are all about. Pretty self-explanatory. Instead of just a single axis that you're rotating around, you're now rotating around multiple axes. And this is beyond just rotating around a single axis multiple times. You can see the example in the upper portion of the slide that first we have the original object position in the far left. Then we want to rotate positively in the x direction and then positively in the y direction. So you can see that we flip the object down through the floor when we rotate around the x direction, and then we flip it around the y-axis when we rotate around the y direction. So now our edge is lined up with the x-axis. You'll notice then in the second illustration, near the bottom of the slide, that we rotate positively in the y-axis and then positively in the z-axis. Now it's important to note that although we have the same exact rotations that we had in the previous illustration, because they're in a different order, our resultant object is rotated in a different manner. And this is an important distinction to make with multiple axis rotation, is that it is order dependent. In a single axis rotation, you could have any combination of positive and negative rotations and it wouldn't matter. But in a multiple axis rotation, you want to make sure that you maintain order as you rotate objects. And that pretty much wraps up multiple axis rotation. That will conclude this module. Be sure to complete the homework associated with this module before moving on to the next one.